Hello friends. So let's begin. Welcome to linear equation. So today we will be seeing the linear equation with PowerPoint presentations. This topic cover in 10th class and we will be seeing linear equation definitions, its standard form and method of linear equation. So in general now linear equation, let me define an algebraic equation that can be written in the form ax plus b is equals to 0 or ax plus by plus c is equals 0, where a, b and c are real numbers and x and y are variables with highest power 1. Notice that x and y are variables with highest power 1. That means this is an algebraic equation. The variable x and y, the highest power is 1. This is an linear equation. Now let us see standard form of a linear equation. Now consider a, b, c, a1, a2, b1, b2 and d are real numbers and x, y, z are variables with highest power 1. Now consider a chart. Now let me explain the terms, definition, standard form and examples. We have first linear equation in one variable ax plus b equals 0. This is a standard form. An equation has only one variable. For example, 2x minus 3 equals 0. Now next, linear equation in two variable ax plus by plus c equals 0. An equation has only two variables. This is a linear equations. For example, 3x plus 7y plus 4 is equals 0. Now next, linear equation in three variables ax plus by plus cz plus d equals 0. This is a standard form of linear equation in three variables. An equation has three variables. For example, x plus 7y plus 4z minus 1 equals 0. Now next, linear equation with fractions. X upon a equals c. This is a standard form of linear equation with fraction. Equation containing fractional terms. For example, 2x upon 3 equals 4. Now next, slope intercept form. This is a linear equation slope intercept form. Y equals mx plus c, where m slope and c is a y-intercept. Equation in the form is y is equals to mx plus c. This is a standard form of slope-intercept form. For example, y is equals 3x plus 10. Now next, point-slope form of linear equations. Equation passing through a point x1, y1. Y minus y1 is equals to m into x minus x1, where m is a slope. This is a standard form of a point slope form. For example, y minus 3 is equals 10 into x minus 5, line passing through point 5 and 3. Now, pair of linear equations in two variables. The pair of two equations a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0. This is a standard form of pair of linear equation. Set of two or more linear equations containing same number of variables. For example, 3x plus 4y equals 4 and 5x plus 7y equals 3. Now we have in general system of linear equations. Let I have showing a general system of m linear equation with n unknowns. a11x plus a12 x2 up to a1n xn is equals to b1. Similarly, am1 x1 plus am2 x2 up to plus amn xn is equals to bm, where x1, x2, xn are variables and b1, b2, bm are constant terms. a11, a12 up to amn are coefficients of any system of linear equations. Now, so we will be saying that the linear equation of two variables, it's solving the method and equations. Linear equation of two variables can be solved by different method as listed below. Method to solve: first, method of eliminations; second one, method of substitutions; third one, cross multiplication method; fourth one, graphical method. Now first we have taken elimination method. For examples, solve the following pair of linear equation by the elimination method: x plus y equals 5 and 2x minus 3y equals 4. Let us see the solution by the method of elimination. Given equation as x plus y equals 5, this is equation becomes 1. 2x minus 3y is equals 4. This is equation 2. When the equation 1 is multiplied by 2, we get therefore 2x plus 2y equals 10. This is equation 3 becomes. When the equation 2 is subtracted from 3, we get, this is equation 3 subtracted from this equation 2. The equation 2 in subtractions, changing sign, positive to negative, negative to positive, and again positive to negative. We get the subtraction to get cancel, become a 0. 2y plus 3y become a 5y. 10 minus 4 gives 6. This is the equations. These equations whole divided by 5. This therefore y equals to 6 upon 5. Now let me substitute the value of y in equation 1. We get therefore x plus 6 upon 5 equals 5. Therefore, to simplify that the equations, x is equals to 5 minus 6 upon 5. This positive value gives the left sides, then gives negative value, is equals to 5 upon 1 minus 6 upon 5. These terms multiply and divides 5. We get 25 minus 6 whole divided by 5. 25 minus 6, it's become a 19. Therefore, x becomes 19 upon 5. Now, the solution is x is equals to 19 upon 5 and y is equals to 6 upon 5. Now, second method we have taken a substitution methods. For examples, solve the following pair of linear equation by the substitution method. For x plus y equals 5 and 2x minus 3y equals 4. Let us see the solutions by substitution method. Given equation x plus y equals 5 is become equation 1. 2x minus 3y equals 4 is it's become equation 2. From equation 1, therefore x is equals to 5 minus y. The positive y taken a left side to give negative y. Therefore x is equal to 5 minus y. Let us substitute this value in equation 2. We get 2 into 5 minus y minus 3y is equals to 4. Simplify that. 2 into 5 we get 10 minus 2y minus 3y equals 4. Minus 2y minus 3y, it's become minus 5y is equals to 4 minus 10. That implies minus 5 divided by 5 is equals to minus 6 divided by 5. 5 get cancelled, gives minus y is equals to minus 6 upon 5. Therefore, the y is equals to 6 upon 5. Therefore, now put y is equals to 6 upon 5 in equation 1. We get Therefore, x plus 6 upon 5 is equals 5. Therefore, x is equals 5 minus 6 upon 5. 5, this term 5 multiply and divides. We get 25 minus 6 upon 5. Therefore, x becomes 19 upon 5. Therefore, the solution we get x is equals to 19 upon 5 and y equals 6 upon 5. Now, third we have taken cross multiplication methods. The pair of linear equation in two variables are a1x plus b1y plus c1 is equals 0 and a2x plus b2y plus c2 is equals 0. Now we get second term, third term, first term, and it's again second term. We find out the x, y and for constant term. b1, b2, the coefficients of y, this is second term. c1, c2, the constant terms. a1, a2, the coefficients of x. And again second term b1, b2, coefficients of y. Therefore, x divided by the cross multiplication b1 into c2 minus b2 into c1 is equals y upon c1 into a2 minus c2 into a1 is equals 1 upon a1 into b2 minus a2 into b1. This value of x and y can also be written as, that implies x is equals to first term and third term gives cross multiplication gives x, and second term and third term gives cross multiplication gives y. Now solve the linear equations 3x minus y equals 3 and 7x plus 2y is equals 20. Using cross multiplication methods, simplify these examples. Let us see the solution. Given equation is 3x minus y equals 3 and 7x plus 2y is equals 20. That implies 3x minus y minus 3 equals 0. This is equation first. That implies 7x plus 2y minus 20 equals 0. This is equation second. This positive value gives right side gives negative. This positive value gives right side. Taken a right side gives negative value. This is a and homogeneous linear equations. Here the coefficients of x and y, it becomes a1, b1 and constant term c1. We get the equations 3 and 4. Now we have find out the value of x and y. First, the value of x. Let me substitute the value of x from equation 3 and 4. We get x is equals to, substitute the value of this from equation 3 and 4, minus 1 into minus 20, minus 2 into minus 3, into 3 into 2, minus 7 into minus 1. Now simplify this. X is equal to 20, negative, we get positive, we get addition, 20 plus 6, we get 26, 6 negative, positive 7, we get 6 plus 7 is equals to 13. Therefore, x becomes 2. 13. Now next we have find out y is equals to c1 into a2 minus c2 into a1, a1 into b2 minus a2 into b1. Therefore, simplify that and let me substitute the value from equation 3 and 4. Y is equals to minus 3 into 7 minus into minus 20 into 3 upon 3 into 2 minus 7 into minus 1. 3 into 7 it has become 21 minus 20 into 3, it's become minus 60. Minus 21, minus minus, we get positive 60. Minus 21, we positive 60, we get 39. 6, negative negative, we get positive 7. We get addition 6 plus 7, it's become 13. Therefore, y becomes 3. The solution of given equations, we get x is equals to 2 and y is equals to 3. Now, let us see fourth, we have taken graphical methods. Now consider pair of two linear equations. a1x plus b1y plus c1 is equals to 0 and a2x plus b2y plus c2 is equals to 0. Now, let I have explained system of linear equations, conditions and types of solutions. Now, consider a1, b1, c1, c2, a2, b2 are real numbers. a1 upon a2 is equals to b1 upon b2. That condition satisfies then equation of systems are consistent and it has unique solution. Next, a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. That condition satisfied, then the given equation becomes consistent but the infinite solutions. That is, it has the infinite possible solutions. Now next, a1 upon a2 is equals to b1 upon b2 not equals to c1 upon c2. That condition satisfied, then the given equation becomes inconsistent but it does not solution exist. That is, no solution. When we solve a system of two linear equations represented by a graph of two lines in the same plane, there are three possible cases. So, let us see the cases first. a1 upon a2 not equals to b1 upon b2. That condition satisfied, the given equation becomes consistent and it has unique solution. That means it has one solution and one common point. The graph gives by intersecting lines. Now next, case second, a1 upon a2 is equals to b1 upon b2 not equals to c1 upon c2. That condition satisfied, then the given equation becomes inconsistent but it has no solutions. That is, it has no common point. The graph will be gives parallel lines. Now case third, coincident lines. It has infinitely many solutions. That is, the condition satisfied, a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. It has infinitely many solutions. It means they have infinitely number of possible solutions and the graph becomes coincident lines. The graph becomes coincident lines means we can see that the lines are overlapping each other. Now next, graphical method examples. For example, which of the following pair of linear equation are consistent? Inconsistent? If consistent, obtain the solution graphically. But the solution inconsistent, it has no solutions. For example, x plus y is equals 5, 2x plus 2y equals 10. Let us see the solution now. Given equation is x plus y is equals 5, its equation first, and 2x plus 2y equals 10, this equation second. a1 is equals 1, a2 2, b1 1, b2 2, c1 5, C2 10. This is from equation 1 and 2. Now I will use showing the condition satisfied or not. A1 upon A2 is equals to 1 upon 2. B1 upon B2 is equals to 1 upon 2. C1 upon C2 we get 5 upon 10. We get 1 upon 2. All are equals. That is, this condition are satisfied. A1 upon A2 is equals to B1 upon B2 is equals to C1 upon C2. This condition are satisfied. The given equations become consistent. Then the solution obtained from graphically. That is, it has infinitely number of possible solutions. Therefore, the equations are coincident and they have infinitely number of possible solutions, and so the equations are consistent. Now, for example, first we find out the coordinates x and y, and will you show the graph? That implies x is equals to 5 minus y. That implies x is equals to 5. So y is equals to 1. 5 minus 1 is it becomes 4. So put the y is equals to 2. Then we get x is equals to 3. Substitute the y is equals to 1. Then we get the x is equals to 2. I will showing coordinates x, y. First coordinate 4, 1. Second 3, 2. Third 2, 3. Now second equation we will find out the coordinates. 2x plus 2y is equals to 10. 2 is common and divide by 10. It become x plus y is equals 5. That implies x is equals to 5 minus y, and substitute the value of y. Similarly, the previous examples, x coordinates, x is equals to 5 minus 1, it's become a 4. X is equals to 5 minus 2, it's become a 3. X is equals to 5 minus 3, it's become a 2. Then xy is this first coordinate 4, 1, second coordinate 3, 2, third coordinate 2, 3. Now let us see the showing graph. So the equations are represented in the graph as follows. This is coordinates are drawn. There are coincident lines, and we can see that the lines are overlapping each other. From the graph, therefore the equation has infinitely possible solutions.